Scaling AWS infrastructure with Terraform, a modular approach for seamless automation. This podcast is brought to you by Business Compass LLC. We are an Amazon Web Services advanced consulting partner. We build and migrate workloads to Amazon Cloud. Our website is businesscompassllc.com. Our phone number is 973-638-2228. Our email address is contact@businesscompassllc.us. In today's cloud-first world, efficiently scaling infrastructure is crucial for businesses to maintain competitive agility. Terraform, an open-source infrastructure as code (IAC) tool, has become a cornerstone in automating and managing cloud resources. This podcast explores how Terraform can streamline the deployment of AWS infrastructure, using a real-world scenario to demonstrate its capabilities. Introduction to Terraform automation. Terraform, developed by HashiCorp, is a powerful tool for automating cloud infrastructure provisioning. It enables developers and DevOps teams to define and manage infrastructure as code, ensuring consistency, repeatability, and scalability. By automating the provisioning process, Terraform reduces the risk of human error, accelerates deployment times, and enhances the overall efficiency of cloud infrastructure management. Overview of Terraform and its role in infrastructure automation. Terraform stands out due to its declarative configuration language, which allows users to define their desired infrastructure state. When applied, Terraform ensures the current state matches the desired state by creating, updating, or deleting resources. This capability is particularly beneficial in multi-cloud environments, where Terraform's provider ecosystem allows seamless integration with various cloud platforms, including AWS. Real-world scenario. Deploying multi-tenant SaaS on AWS. Consider a multi-tenant software as a service (SaaS) application hosted on AWS. Each tenant requires isolated environments with specific resources, such as VPCs, databases, and application servers. Manually setting up and managing these environments is time-consuming and prone to inconsistencies and errors. Case study of HumanGov's application deployment for U.S. government compliance. HumanGov, a company providing SaaS solutions to various U.S. government agencies, faced significant challenges deploying compliant infrastructure across multiple AWS regions. The need for stringent security, high availability, and regulatory compliance added complexity to their deployment process. Challenges in manual deployment. The traditional approach of manually deploying infrastructure could have been more challenging. Each environment setup required extensive team coordination, careful resource configuration, and meticulous documentation to ensure compliance. This process was labor-intensive and vulnerable to misconfigurations, which could lead to security vulnerabilities and downtime. The complexity and time-consuming nature of manual infrastructure setup. Manual deployment is inherently complex, involving numerous steps and checks to ensure each resource is correctly configured. The time required to deploy even a single environment is significant, delaying application delivery and increasing operational costs. Additionally, scaling the infrastructure to accommodate new tenants or services exacerbates these challenges, leading to inefficiencies and increased risk. Proposed solution. Leveraging Terraform for scalable automation. Terraform offers a robust solution to these challenges by enabling scalable, repeatable, and automated infrastructure deployment. By defining infrastructure as code, HumanGov was able to automate the provisioning of AWS resources across multiple regions, ensuring consistent and compliant environments for each tenant. How Terraform addresses scalability and efficiency in infrastructure deployment. Terraform's ability to manage complex dependencies between resources simplifies the deployment of large-scale infrastructure. Its modular approach allows for code reuse, enabling teams to quickly build, test, and deploy environments. Terraform also supports automated scaling, ensuring infrastructure can grow or shrink in response to demand without manual intervention. Enhancing productivity with additional AWS services. HumanGov integrated additional AWS services, such as AWS Cloud9 and Code Commit, to further streamline its workflow. These services enabled collaborative development and version control of Terraform scripts, enhancing productivity and reducing errors. Introduction of AWS Cloud9 and AWS Code Commit for streamlined workflow. AWS Cloud9 provides a cloud-based IDE that integrates seamlessly with Terraform. It allows teams to write, debug, and run Terraform scripts collaboratively. AWS Code Commit, a fully managed source control service, ensures that Terraform configurations are versioned and stored securely, facilitating collaboration across distributed teams. Modular approach in Terraform. A modular approach in Terraform emphasizes code reuse, making it easier to manage and scale infrastructure. By breaking down infrastructure components into reusable modules, teams can maintain clean, organized codebases that are easier to update and extend. This approach improves efficiency and ensures that best practices are consistently applied across all environments, emphasizing clean code principles for efficient infrastructure management. Applying clean code principles to Terraform scripts ensures readability, maintainability, and scalability. By organizing code into logical modules, teams can avoid duplication, reduce complexity, and streamline the process of managing infrastructure changes. Storing remote state and historical data. Managing the state of infrastructure is critical to ensuring that Terraform can accurately apply changes. Terraform state files track the current state of deployed resources, and storing this state remotely provides additional benefits such as collaboration, security, and backup. Best practices for remote state management using DynamoDB and S3 buckets. For remote state management, it is recommended to use Amazon S3 for state file storage, combined with DynamoDB for state locking and consistency. This setup ensures that multiple team members can work on the same Terraform configuration without risking state corruption, providing a robust and scalable solution for managing infrastructure state. Conclusion: the future of infrastructure deployment. Terraform has revolutionized the way infrastructure is deployed and managed in the cloud. Terraform enables organizations to scale their infrastructure efficiently and securely by automating complex tasks and promoting clean, modular code. For companies like HumanGov, Terraform addresses the challenges of manual deployment and paves the way for future growth and innovation. Summary of benefits and recommendations for implementing Terraform in AWS. Implementing Terraform in AWS offers numerous benefits, including scalability, consistency, and efficiency in infrastructure management. By adopting a modular approach, leveraging additional AWS services, and following best practices for state management, organizations can significantly enhance their deployment processes and position themselves for long-term success. Thank you for listening to our podcast. Please share this podcast, visit our website, and follow our social media links.